Hello everyone. So we are diving into an important topic in the world of large language models. That is how to improve their reasoning abilities, especially when the chain of thought prompt strategy doesn't quite work out as planned. So now, if you have worked with LLMs, right? So you probably know that guiding them to reason more effectively can be a bit tricky. Sometimes, when we give them step-by-step prompts, they still miss the mark. So today, I'll share some strategies and examples to tackle these challenges more effectively. Let's get started. So to set the stage, so let's talk a bit about chain of thought prompts. Essentially, a COT prompt encourages the model to think step by step, which often leads to better and more structured reasoning. This method can be really effective for tasks that require multi-step logic, like math problems or decision-making processes. So instead of getting a quick one-word answer, we guide the model to show its work by laying out each step in its thought process. But of course, as with any method, it's not always foolproof. Sometimes the model response still falls short, even when we ask it to break down things. This is where our troubleshooting comes in. So let's first talk about some of the challenges with a complex task. As we know, LLMs are great at answering direct questions. But when it comes to multi-step problems, like solving math word problem or making a series of logical deductions, they often fall short. Why? Well, a standard prompt might push the model to generate a quick answer without going through unnecessary steps. This can lead to incorrect answers or solutions that lack depth. For example, a model might skip steps in a word problem, missing important calculations, and giving an incomplete or wrong response. So, how do we solve this one? So, that's where CO2, COT prompting comes in, and we will look at why it works in the coming slide. So, all right. So, let's discuss why COT prompting is such an effective solution in order to bring a reasoning into the LLM's response. So, with COT, we guide the model to go through each reasoning step one at a time. This approach not only improves accuracy because it reduces the chance of skipping over parts of the problem, but also provides transparency. Now we can see the model's thought process, which makes it easier to trust and verify each answer. One of the best parts, that is, the COT is versatile. It is useful in fields from math to logic and even in planning tasks. So COT prompting isn't limited to one domain. It can enhance reasoning across wide range of applications. Let's consider a simple example to really demonstrate the difference between the COT, that it can make a difference from the standard prompt. That is how a COT can make a difference from the standard prompt. Consider a simple math problem. Suppose, for example, I suppose a Praveen has 12 apples. Okay, he gives 3 apples to each of his 3 friends. How many apples does he have left? Okay, so without COT prompting, the model might jump to a quick answer, potentially getting it wrong by not considering each step. It could skip calculating the total apples given away, leading to an incomplete answer. But with COT, the model goes step by step. The first multiplying the apples given to each friend, then subtracting that from the total Praveen had. This guided reasoning results in the correct answer. So what is the takeaway here? The COT prompting helps LLMs reason in a structured way, leading to more reliable answers, especially for complex problems. So what are the common use cases associated with the COT prompt? So COT prompting helps especially in mathematical reasoning, complex problem solving, and the decision making tasks. So far we have discussed what is COT and where it helps, right? Why it helps also. Now comes to the actual the topic of interest when it comes to this presentation, that is what can be done when we see or when we see what it doesn't work as expected. So what should we do? So our first step is to diagnose the failure, right? So why might the model not be able to follow through on a prompt that asks it to think in steps, right? So there are a few usual suspects here. Sometimes the prompt itself is a bit ambiguous or lacks clear, specific instructions. Other times, we might be asking about something complex without providing enough background, leaving the model with too little context to reason effectively. And occasionally, the question might be just too complex to handle all at once. So, how do we pinpoint the issue? So, I recommend taking a closer look at the responses the model is giving you. Is there a consistent misunderstanding? Are certain parts of the answer missing? So once we have identified the problem, we can move to potential fixes. So what are the potential fixes once we identify COT fails? Okay, so once we have identified the some common issues associated with the COT, when COT fails, so let's talk about now how to fix them. There are four key strategies. First one is refine. What is that refine? Refine the prompt itself. Often small tweaks to the wording can make a big difference. If the prompt is clear and specific, the model has a better chance of staying on track. So what is the next strategy? Adding enough context. If the model doesn't seem to understand the scenario, try adding more background or relevant examples. This helps guide the model towards the kind of answer you are looking for. So another great approach is simplifying the complex problem. So breaking a big question into smaller parts can make it easier for the model to reason step by step without getting overwhelmed. Lastly, feedback loops. Sometimes the best way to guide reasoning is through follow-up questions. For example, if the model misses a point, ask a clarifying question. This can help refine its answer in real time. So to wrap things up, let's look at a quick case study that shows how these strategies can come together. So once you have that case study and once you identify like the COT is not working as you expected, so what we need to do is we need to identify the problem by closely observing the response of the model, right? So after identifying the problem, we refined the prompt and added some context and simplified the problem within the prompt itself. So with these tweaks, the model reasoning improved significantly. So here are the key takeaways. First, clarity and specifically really do matter in the prompt. That is, clarity and specificity really do matter in prompts. The clearer you can make it, the better the model's response will be. So adding context can give the model much needed guidance, and using an iterative approach with feedback loops can refine the model's output further. So thank you. I hope you found these strategies really helpful. Thank you.